Okay, there we go. There you go. I think this lesson's going to be very fast. Not, well, very, but my goal is to have us done by 1, so you can spend the last 15 minutes working on homework. So that's my goal. I hope you share the same goal. If we don't make it, then it's okay. But we today are going to be investigating patterns involving polygons, just like we've been doing in the previous couple lessons. So, Chris, Owen, hurry back, get healthy, whatever you need to do. Don't bring back disease with you, because that's how zombie apocalypses start.
Oh, okay.
Really?
Well, I mean, probably somewhere along the line, somebody. All right, so what about an infinite polygon? Or really, the question is just an any-sided polygon. Can we make some rules? Can we make some patterns? Can we make some general formulas that help us solve, for the things we're wondering? So the reason I asked you guys to be in 3 groups is we're going to split this list up into 3 sections, and then we're actually going to make the last 3 just kind of bonus, or whoever gets done with their 3 first, then you can do whatever. So gentlemen in the back, I guess, what do you want? ABC, or do you want DEF, or do you want GHI? Choose a row going across. First one, sure. You guys are doing this one. I guess all of the females, if Ava is over with them. Do you guys want DF or GHI? GHI?
Alright.
Well, she answered first. And it leaves Gunnar and Colin to do square, nonagon, and 60-gram. So, your goal, if the radius, quote unquote, of the polygon is 1, what is the perimeter and area of your 3 gons? So not that the edge is 1, but the radius of the polygon, like we discussed last week, goes from the vertex to the center. That's your radius of the polygon. Are we good? Are we clear?
You're doing H? Sure.
So I guess we'll say Chris and Owen, you guys have to do JKL.
I'm doing right now.
I mean, if this was live feed, I do wonder if they were sick.
Huh? Oh, yeah.
That would be cool.
Ava, we're doing all of them.
And for the record, Pettigrew makes the best rounds. If you guys are doing all, you have to do yours first at least, please.
Okay.
So from the center to the vertex.
I was gonna get some batteries. I forgot. It's a prank, bro.
Yeah, that's gonna just smell weird. So. All right, 7th grade, please just get down to business.
Monday, my plan goes for
Alright, just cross off Friday.
What are you doing? That's 10, right? That's like, are we doing GHI? Yes. Ava, we're doing GHI, right?
There are girls in the scientific class that think I say really antiquated statements, so I searched up the list of old timey sayings.
If I want to go off the reference, how would I draw like a 60 gon? Should I just...
Really just draw one of the triangles. So,
okay.
your reference for a 60-gon, you would want to just make one of the triangles, where if there's 60 of those, then each of the vertex angles or center angles, whatever you want to call it, would measure how much?
Oh,
6, right? So there's your 6 degrees. Then this creates an isosceles triangle, right, where both of these are 1, because you know that the radius of the polygon radius. So then these split the other 174 degrees. So 87? Would that be right?
Oh, I did my wrong. I did mine wrong.
Yeah, I gave you these nice things. You just throw it.
Sure.
I don't know how that happened.
My group with the triangle. Do we have perimeter area of that yet? Okay. Do you...
Oh, Decathlon has 10 sides, right?
Yes. Deck is 8. You want it verified? Alright. What do you got for perimeter? Oh, we're going decimal. Did you read in the directions where it said to round to the hundredths?
We just get sense that the area is
No.
smaller than the perimeter.
Yeah. Because remember the different units. It's not. So try that one again. So remember, the triangle you're working with is composed of 3 triangles. So if you think of this being your big triangle, where this is 1, and this is 1. So this is... Okay. Go back and check that. Who's got square? You got the square?
You divide.
Perimeter?
1 divided by that, because we have x over 1, right? Oh no, you multiply, right? Sorry. You multiply by 1, that's still 0. Yeah, I know. I divided.
Square.
So you got it wrong? You got it.
Oh, wait, no, I did something wrong.
7, 7, 8, 5, 2, 5, 2, then multiply by 5, right? 5. Did you also get this number? Jenny? Did you also roll this pattern? Is this still G? Yeah. Wait, so if we got this, you multiply by 5, right? Do you have the height already? Just do cosine 36.
What gets weird is if you try to draw these things.
So what's cosine 36?
So right now what I have drawn over here on the bottom is not at all what it actually looks like. Because this small part of that angle would be 60. Which means this is my long leg. And we have a 30, 60,
Okay.
And in a 30, 60, 90, what's the rule about legs compared to hypotenuse? Anybody remember 30, 60, 90 rules?
Yeah.
How's the hypotenuse relate?
The hypotenuse is 2 times the short leg.
2 times the short leg. So this is my short leg. Now I'm solving the triangle for these guys back there. So then my long leg, and this gets funky. Radical 3, right? Because that's my longer leg. Although it doesn't look like it, that's my longer leg. Not drawn correctly. Not even to scale, it's not drawn correctly.
You should just put that, not drawn correctly.
Anyone want to verify theirs to make sure that they're doing it right?
Yeah.
What do you got?
Actually, make them right on my group.
For the area. Area? No.
Wait, guys.
Oh my god. Did you multiply with the whole base or just?
Wait, let me see.
That is my problem. Oh my god.
area.
This is
Yeah.
It is.
Yeah. 3. It says to round to the 100, so it's on 2. Yeah.
2.38.
Yeah. Call me everyone and finish the other one.
You guys have one?
Oh, yeah, we have the first one.
Which one's your first one?
Regular pentagon.
Switch up to the area.
Yeah.
Yeah, you got it right.
So the pentagon has perimeter what?
The perimeter is 5.8.
Yep.
And then the area is 2.38.
I have the other 2, but we have
I have to work on the other 2.
I did the bottom.
Give me yours.
You know, squared, you told me that the perimeter wasn't 80.
What?
80 down 134.
Oh, can we just use the same
So you're
triangle?
shooting for 5.66.
Right?
So let's
Just
look
use
at
the
this
same
one.
triangle.
The square
Oh yeah,
where this is 1. And it actually meets the corner. Shut up.
10 sides, right?
So we know this is a right angle. So each of these is a 45.
10 sides.
So we have another special right triangle. How do the legs relate to the hypotenuse?
Square root
And which
What
one's
is everything
longer?
end 9944?
2. Sorry.
Which one's longer? Hypotenuse to the legs.
The hypotenuse.
So how do I get from the hypotenuse to the leg?
You still use
Gonna make it
like
bigger.
cosine equals adjacent.
So when you go back and you check your work, ask yourself questions to drive you to figuring out where your mistake was. If I have to get small, because radical 2 is still approximately 1.4. For what number times itself makes 2, it still has to be bigger than 1. So we have to divide to get to the leg. Be real careful with special right triangle rules. Hey guys, do we have any to verify? Because every time I look back there, we're just kind of laughing and looking at each other.
I have the list of the triangle.
Okay, what do you got?
For area, I got like 1.3.
Yeah, area is 1.30.
Yay! And then for the perimeter,
Sorry, area 1.3.
and for the perimeter, I got 5.2.
It is 5.2.
I got area. Is it
Keep rolling.
You have to round. Yeah, probably round. What's perimeter?
What do you mean? What seems too small?
90.
What do you have? That's correct. Have confidence in your math. Dude, the inner length is 1. These shapes are small. Like whatever unit we're working in, here you come. Because I'm going to add it, but they just gave me 1. So you said 2.83 for the octagon's area. And did you find the perimeter of it? 1.2 actually, according to the book. I don't know if that came out as a rounding mistake. I mean, you're close enough. You're good. But what do you got? Decagon. What do you got? Perimeter?
Perimeter 6.18. Yeah.
Area?
And 2 and 94.
I like how you say that. We're filling stuff in, but we seem to be skipping lines.
Whoa.
Yeah, we're 30 lines. No.
We have square or nonagon. Square, what do you got?
The area, I got unit squared.
Yep.
And for the perimeter, I got 5.667.
Times 90. Got for area, I got 3.139. Area of 90 gone, so 3.14.
Nice. Wait, which? You have the 60 gone
That
too.
is not big.
And the non.
I got 3 points.
I got 61 points.
What do you
For the
have?
area, I got 20.
So,
Wait, what'd you do?
the non-one, I have an area of 2.39.
You multiply the base of 5, right? And then you multiply by 90, right? What'd you get?
How you doing, Gunner?
So this is what I got for
Does it make
3.1.
sense?
I also got 3.
And perimeter of
Yeah, so this is what I got for this side of the base, right?
Yeah, and then I
And then
multiplied
you
it.
and then you find the height, and then you just multiply it, and then
That's
multiply
also
that
what I
by
did.
90.
Wait, what'd you do?
Gentlemen,
Okay,
back
yeah,
in
you
the back,
multiply
is it making
base
sense?
height, and then you
Oh,
multiply
Just
yeah.
taking a little bit.
Yeah.
That's what I
And
did.
the trick,
Wait, what'd
it
you
works, it just takes some
That
time.
same thing. So,
60 gone?
Yeah.
What
I
do you
can't
got?
read.
I
Oh,
have
Yeah.
sine is
No, I have
sine.
an area.
You didn't put sine 20.
Sine 20?
What? Sine 2.
Yeah.
You did sine 20.
Probably forgot to put a 0.
That's a 7.
7? 70?
That's
What?
70. What'd you do sine 7? Did you subtract it?
Wait,
For
Nice.
90 gone? Yeah. No, because if you divide 90 by 30, 360, that's 4 for the vertex angle. Oh.
Ava, are you trying to mislead us?
No, I got 40.
Anyway.
Well, I got the other one right, so it's fine. What's the perimeter? Yep, find it. I was like, what? Wait, what's your 3.199 over 9 here? 67 times 2 equals that times 90. Perimeter is 6.28.
We finished. Are you sure?
What else you got for me?
The 90 gone.
90 gone.
Okay,
What do you got?
so area is 3.14 units squared.
Okay.
Perimeter is 6.28 units. It's double!
Wait,
But they're different units. So
Wait.
you can't really say they're double.
I'm sorry.
What'd you double?
I failed myself.
Wait,
Oh, yeah.
You're right to apologize. You're
What'd you
my
do for
personal
perimeter?
is this right here
Take
making
this, multiply by 2.
You're gonna have to tell me.
Multiply that by 90.
It's not my job to tell you. I mean, maybe it's my
You
job to
take
tell
this
you.
because
But
this is
Cosine, right? So you
what about the
No,
hexagon?
use sine.
Did we get that?
Just use sine to find the
Yeah,
x
that
right
was
down
good.
here and multiply that by 2 to find
Oh, yeah,
the
you
x
did.
one time.
So you multiply by 9.
You have the 30 gone?
Oh yeah.
What do you got? The area should be 3.12. For the 30 gone, yeah, it should be 3.12 and 6.27.
Oh my gosh.
Don't
Their
round in the problem, round your final answer.
Wait.
So I don't know if you rounded within the problem somewhere.
area. You bring nothing together. So we're double. That like equals the ratio.
not the golden ratio. It's a special ratio.
Is that the answer?
Talk with your group for a moment
Hey, Ava.
on what observations you see from this table.
It goes up.
They slowly get bigger.
Wow.
They get bigger.
As they get bigger, they get better.
Actually, there's a lot of
No, they always get closer together. Closer together, so they're the same. And when they're the same, they're double. I can see.
Yeah.
What? It could actually be
60, 90, 180.
Oh, because it gets closer to being a circle, right?
Is that it?
Yeah!
And
Good job, yeah.
Yeah, you figured it
go
out.
on Desmos. I never let you make it, but well, I don't know if we'll let you make a billion. But you can't see the edges till you zoom way in. Well, when you zoom out, it looks like a circle.
Oh,
We
and
figured
also
it out.
areas have a perimeter, right?
They're different units.
Oh.
So
the
kind
numbers.
of, but
Ew, why is
not
it
really.
The numbers.
So you can say, you can say that numerically, but be careful actually thinking they're half. Because you gotta tell yourself they're different units.
Yeah, sure, but
So, okay, so Ava's very passionate. Ava, take the floor. What observations do you want to state for the class?
okay. Well, I mean, as we keep going and there are more sides,
You might as well just
there's nothing.
get your books there.
Just go. Nobody else has a chance to do that. Just
Well,
go.
it gets bigger and bigger and bigger until we hit here, where it's just like the changes are so minute that it's like beyond the hundredth. Because as you get more sides, you get closer to being a circle.
That's what you said, actually.
Yeah.
That was in the past, Jenny.
So it goes do. And also for
Nice.
some reason, this times 2 is that.
Yes, for some reason. And that, and that, and that.
No way.
Good idea. No, thank you.
Wait, the perimeter's the circumference, and then the area is in the circle.
That doesn't make sense. Why would the perimeter be twice the area? That can't really be.
That's all.
Ooh.
The
perimeter is 4 times the area.
It can be.
The perimeter's 4 times the area. Yeah.
Like a circle. It's comprised of infinite sides.
Wait,
What is the length of one of those infinite sides?
Infinitely small. Infinitesimally small.
So 1 over an infinite.
Well, it depends on, 1 over however many sides. Well, it depends. It'd be relative, but very, very small. So, to breeze through very quickly the next sets of problems, as we look at this, we ended up seeing, and as we got closer and closer and closer, well, or bigger for a number of sides, why does this make sense? What were we working with that caused this to happen?
radius.
Okay, what?
We're working with the radius of the shape. That's supposed to be the radius of the circle. And the radius of the circle, we multiply that out.
So,
There's no connection except that
Well, you
3.4 is in a circle and the radius is the same as the.
okay, so you keep saying circle. So if I relate this to circle, I'm going to put a question mark.
Oh,
there.
yeah. Pi times 2 is 6.283185307. Really? Oh.
Really?
Wow.
One squared.
Say again.
The radius is 1 squared.
Squaring 1
Yeah, so.
doesn't do anything.
Yeah, okay.
Whoa.
Doubling 1 most definitely does something. Right? So this rule won't hold true except for situations where the radius is 1, because then squaring it doesn't have an effect. But if we look at a different situation, say a radius of 1 compared to a radius of 3, well, we already know here our values for perimeter or circumference, really, if we want to just go ahead and say it's a circle. So what's perimeter and area here? Take a moment. Perimeter and area here. Ryan, you got it? Because I know you're talking, even if your hand is in front of your face, it's really easy to tell that you're talking.
What should we round to?
So you.
You got it there.
No.
Hundreds is normally safe.
Outside.
I like thousands. But
Which is weird.
didn't we observe something last week about ratios, comparing perimeters and areas and things like that? What was that?
Oh,
It was the scale factor squared, which is
yes,
the area
yeah.
thing. Yeah.
the area. So it increases exponentially. That'd be fun to graph that. I should do that.
So then, if we start talking in pi units, so if we go back to so we think about our original circle, and instead of using round to the hundredths, we think in pi units.
My mom's birthday is coming up.
That's true.
Her birthday's on Pi
What is
Day.
the point of me being at the board?
I'm sorry, your birthday's on Pi
It's
Day.
not like it matters. No, that matters.
Oh!
Yeah, it's not like it matters that I'm up here. It doesn't keep your focus. It just-
No.
Well, I mean, it's her mom. It's her mom's birthday.
What is
Cutters.
the perimeter of a circle with radius of 1 unit?
2.6.28. Yeah, I agree with Jenny.
Yeah, 2.8.
Or 6.28075339.
This, as we referenced really briefly last week, is the unit circle. These are radians. When we talk about trig working in radians, this is where it comes from. Because essentially, my perimeter will be 2 pi times whatever my radius is. So we call it 2 pi radians, because once I know the size of my circle, I know the measurement.
Can you also, is that for figuring out like when you have like a curve triangle like a cone?
Arcs.
Yeah.
Yep. So parts of the circle, not going all the way around the rotation. But so then what would like half a rotation of a circle be? Half the distance around? What would that be? If all the way around is 2 pi, just pi, right? What about a quarter of the distance from here up to there? Half a pi, right? Half of that, we do a quarter of a pi. And we can start to actually make triangles in here, right? Because if I make a triangle right here, going right there, how many degrees would be inside of here?
A certain number.
Well, how many degrees would have been here? 90.
45.
So that'd be a 45, 45. If I had like a drop line right there.
Wait, but the outside is curved.
Yeah, the arc is going to be different, but this is where unit circle comes into play. We're not going deep into it today. Okay? I just wanted to show this is where it comes from.
Sounds like fun.
So, once we change the radius, say we have a radius of 10 units or 100 units or anything else, we work with that value in the base unit circle. Alright, do we just want to solve some more homework problems and see what maybe gives us issues?
Yeah, homework.
People at home feel better.